Okay, we have liftoff. Alright, we looked at things that were yesterday that were exponential functions. I'm going to give you two forms right here that you need to write in your notes. Something is going to be written in exponential form, E-X-P-O-N-E-N, maybe exponential form. It's going to be a base to an exponent is equal to a number. Okay, that's exponential form. Logarithmic form will be the log of base b. The number is equal to e. Okay, so we can, you remember this from Algebra 2, we can exchange those b's, e's, and n's, but you got to make sure you put them in the right spot. Okay? Alright, so the first thing we're going to do before we start actually solving any is just make sure we can rewrite them in both ways. People, the common question when we do this in Algebra 2 every year is, what are logs even for? Logs gives you another way to solve for an exponent. The way we did it yesterday, we got them to have the same base, but not every time do they have a compatible base like that, like they all did yesterday. You were nice and easy with 2's and 4's and 3's and 9's and stuff like that yesterday, but they might not always be that way. Then you would have to use a logarithmic equation. Alright, so let's start here to see if we can rewrite some. Let's say I've got 2 to the 5th is equal to 32. Okay, there's nothing to solve there, that's just a true statement. 2 to the 5th is equal to 32. First off, tell me, is that exponential or logarithmic form? Exponential. That's a no-brainer question. It's exponential because it's got an exponent. If it was logarithmic form, it would have a log. Okay? No brainer on that. So let's label our stuff. If this is exponential form, will the 2, what will it be? The B, the E, or the N?
The B.
Very good. Everybody can label this stuff. What's our 5?
E.
Alright, and our last one? Okay, so we're just going to plug that stuff in over here in the log form. So I'm going to say the log of my base, the B, which was 2, so it goes down. It's that, what's that called, when you drop something down? Has it got a name? Oh, I thought maybe there was like a grammatical name or something. I don't know. Just base, I guess. And then our N is 32. And our E was 5. So just rewriting back and forth into log and exponential form. Okay, let me give us one more of those and then we'll just get to solving. Let's say I've got log base 8 of 4 is equal to 2/3. Subscript, would that be subscript when it drops it down? Alright, so is this exponential or log form? Log, very good. It says log, it's log form. That's a tough question there. So we're going to rewrite this log form in exponential form. So let's label all our stuff. What is the 8? It's the B. What is the 4? N. What is the 2/3? E. So when I rewrite this to exponential form, you'll remember from the Algebra 2 when we watched that Crazy Man video, it spells bin. So I'm going to say B to the E is equal to N. Almost wrote an N, that's why my 4 looks crazy. B-E-N. It doesn't spell bin in log form, it's like beneath, but it spells bin in exponential form. You remember that when he was talking about calling his friend Ben? That was so weird. But we remembered it.
What if you named your kid Beneath and they were like, why is my name Beneath? And you were like, log function.
I don't really know. My mom is a moron. Alright, let's use that info to actually solve some equations now. I've got log base 3 of x is equal to -3. Alright, so when we're in log form and we've got that variable in there like that, we're going to try to rewrite that in exponential form to solve. So how would this look if I rewrote this exponentially? 3. Valentina's the only one that knows the base. There you go, Valentina and Angie. Good job. And now you can calculate that. You need to do it in the calculator or in your head. Either one, it's pretty easy because you know 3 cubed, 3 times 3 is 3 is 27. And since it's a negative, what happens when you have a negative power? Goes on bottom and becomes positive. So the whole main dilemma from that just came from being able to rewrite it. Once you got it rewritten, it was easy to go. Okay. Here I've got log base 1/3 of 2x plus 5 is equal to 2. Alright, so rewrite that in exponential form. How would I read that in exponential form?
1/3
Very good. Girls over there have got that down good. You don't have to put that 1/3 in parentheses like I threw at the last minute. I just do to remind myself when I square a fraction, you got to square the numerator and the denominator. So that's the only reason I did that. So that makes that 1 squared is 1 and 3 squared is 9. Now you got a 2-step middle school equation to solve. You don't like it because it's got a fraction in it, but you still solve it the same way. What would you do to get rid of that plus 5? So you got to figure out what 1/9 minus 5 is now. You got that, Angie?
It's like it's a fraction. It's 44 over 9. Or
It's negative though, isn't it? Did you do the 1/9?
Oops. I did 5. Yeah, it's negative 44.
Negative 44 over 9 is equal to 2x. And then x will be multiplied by 2, so we just divide by 2. Negative 22 ninths. Whoop, whoop. Alright, now let's look at one where our base is a variable. Everybody alright? I've got log base x of 5 is equal to 4. Alright, so what would that be? X to the 4th power equals 5. Looks difficult, but it's really pretty easy. How do you undo a 4th power? 4th root. Very good, Bailey. And 5 is not a perfect 4th, so we're just going to leave it as the 4th root of 5. Alright, we had an answer that was in radical form there, so let's do one now where the problem starts out with a radical in it. Let's look at log base 36, that's random, of the 4th root of 6 is equal to x. Log base 36 of the 4th root of 6 is equal to x. I think I actually, when I was doing new bell ringers this morning, I did one similar to this. Okay, the girls set it over here. Be 36 to the x is equal to the 4th root of 6. Alright, that doesn't really help me a whole lot. Now, I need to try to figure out something about that 4th root of 6. Do you remember power over root, power over root? I can rewrite the 4th root of 6 with a power. Very good. It's 6 to the 1st power and a root of 4. So that's the same as 36 to the x equals 6 to the 1/4. Alright, we're getting somewhere now. This is like yesterday's stuff. 36 and 6 share, I could rewrite that with a base of what? 6. 36 is 6 squared. And it's got an x up there, so I put that x back. This 6 to the 1/4, I don't have to change it. It just stays 6 to the 1/4. Good. Now, just like on the bell ringer, 6 equals 6, so we just set our powers equal to each other. Divide by 2. 1/8 is correctamundo. Alright, I'm going to show you some special situations now, and then I'll talk to you about how to use your calculator when you can on these, and we'll be getting there. Let's look here. Let me just throw a bunch of these up here at once. Log base 12 of 12. Log base square root of 3 of square root of 3. Log base 3 of 1. Log base 0.4 of 1. Alright, so we've got those 4 problems. The directions for those 4 problems say to evaluate the log. If those are in logarithmic form, and they are because they all got logs in them, what piece is missing? The B, the E, or the N? The E. So those are all equal to the E, right? So if I wanted to rewrite these in exponential form, this would be 12 to the what is equal to 12, right? Because it's base and number. So I don't know the E. B to the E equals N. So what is that? 12 to the right. So in this case, it would equal 1. Okay, here's how this works. When your base and your number are the same, your exponent will always be 1. Base and number are the same, exponent will always be 1. So what would the answer to this thing be? 1. It's that simple.
14
Base and number are the same. It's a 0.4. So the exponent equals 1. Alright, now this next one, the base and the number aren't the same. So let's look at how this would work. Again, it's the exponent that you're missing. So you would say 3 to the what equals 1. What power is it that you can raise anything to, and the answer is always 1? 0. Very good. So what does that have to be? 0. So anytime you're taking the base of a 1, your exponent will always be 0. So what will this last one be? 0. Very good. Alright, we're supposed to talk about graphing these, so we'll do this real quick because I'm going to take the easy way out on graphing these. If I'm told to graph f of x equals log base 4 of x, I'm going to do that in my calculator. Okay, I could, y'all know I like to make input-output tables, and I could do that. Wouldn't be too terribly difficult, but when I get to graphing logs, I bail and go to the calculator. But there's something special you got to know to do that. So grab your calculators and we'll go through the steps to graph this in our calculator. I'll get me an axis ready since I didn't get a piece of graph paper. Alright, we're graphing. We hit y equals, so get there in the y equals. Now, some things, and you'll remember this from Algebra 2, some things about the log button. On the far left side, it says log over there about midway down. Do not push that. That log that just says log with nothing else is an understood base 10. So anytime you push that log button over there on the far left about midway down, it does log base 10. We've got a log base 4 here. So to change the base of it, you're going to hit math, scroll it all the way down until you see something that says log base. Pick that, and then you can fill in your base and your number. So in this case, our base is 4 and our number is x. They need help finding that log base.
All I did it was like in the exponent one, how to change the box on my point.
Alright, go then after you get it, go to your table And give me a few points to plot. Hit second graph and go to your table.
There's
1, 0, 2.5, 4, 1. So it's just a little curve there. And then 8, yeah, we'll keep going. Alright, I think it doesn't it keep coming down like this a little bit. Alright, so you'll be able to do that. You'll know how to find the log base and go and yeah. So when it starts getting to, is it 0 where it'll give you that? Mm-hmm. Yeah, good. So that means Blake told us yesterday that y-axis would be an asymptote. It can't touch it, it just gets close to it. Very good. Alright, so now, since you know where that log base button is, back on your normal calculating screen, if you were told to solve this, x equals log base 27 of 3, you've now got choices on how to do that. The way I did it just a second ago, I rewrote that in exponential form, so it would be 27 to the, what? X. Didn't I just flip it? 27 to the x equals 3. This is the way I did it a second ago. Then I'll go with you on your calculator. So I would need a common base. 27 is the same as 3 cubed, and it still has an x. 3 is just 3 to the first. Okay, this is the way I did it earlier. So now 3x would equal 1, which means x would equal 1/3. But now, since you got reminded about the log base button on your normal calculating screen, you can just hit math, scroll it down to log base, and fill in that base of 27 and a number of 3. Did you get it? Anybody trying it? Good, good. And I know that's how y'all want to do it. Y'all little button pushers, you. Alright, what do you think on that? Pretty easy, I concur. We've got some properties of logs, but those are in the next lesson. So it'll be probably next week at some point when we get that. We're going to do some assignments coming up the rest of the week to get some practice on all this stuff. Alrighty? Yep. You got it, dude. Alright, we'll pause for there today.